Have you ever wondered why the periodic table is so important in science? A seemingly simple chart, yet it holds the keys to understanding the building blocks of the universe. The periodic table is our map of elements, the ingredients that compose everything around us, from the air we breathe to the stars in distant galaxies. It's a testament to human curiosity and the quest for knowledge. So, what makes it so significant? Today we unravel the mystery behind the significance of the periodic table in science. Our story begins in the mid-19th century with a brilliant scientist named Dmitry Mendeleev. Born in Siberia, Mendeleev's life was marked by a relentless pursuit of knowledge. He was a chemist, a teacher, and a visionary, but he is best known for one of his most significant contributions to science: the creation of the periodic table of elements. Imagine the world of chemistry before Mendeleev's periodic table. Scientists knew about elements, those fundamental forms of matter, but they lacked an organized system to understand how these elements relate to each other. It was like having an orchestra of instruments without a conductor, a jigsaw puzzle with no reference image. That's where Mendeleev stepped in. Mendeleev was not the first to attempt to order the elements. Other scientists had made attempts using properties like atomic weight, but Mendeleev's approach was unique. He arranged the elements based on their atomic weight, yes, but he also considered their chemical properties. He started to see a pattern, a periodicity, and he created a table that reflected this. What set Mendeleev apart was his foresight. He noticed that not all elements known at the time fit neatly into his table. Instead of forcing them in, he did something remarkable. He left gaps. Mendeleev predicted that these gaps represented undiscovered elements. He even went so far as to predict the properties of these mystery elements based on their proposed location in his table. Time proved Mendeleev right. As new elements were discovered, they slotted perfectly into the gaps he'd left. His table wasn't just a snapshot of what was known in the mid-19th century, it was a roadmap to future discoveries. Mendeleev's revolutionary table laid a solid foundation for the study of elements. It was a tool that helped scientists make sense of the natural world, a common language for chemists across the globe. More than just a table, it was a testament to the power of scientific insight and foresight, and a reminder that sometimes, to move forward, we must leave space for the unknown. But the periodic table didn't stop evolving with Mendeleev. Science never stands still. After Mendeleev's groundbreaking work, the periodic table continued to evolve and expand. As scientists discovered new elements, they found their rightful places within this ordered system. The discovery of noble gases like helium, neon, and argon, for instance, led to the addition of an entirely new group to the table in the late 19th and early 20th centuries. These gases, with their stable electron configurations, introduced a new concept of atomic stability to the scientific community. Around the same time, scientists also began to understand the significance of atomic numbers. Before this, the elements were arranged mainly based on atomic weights. But as we delved deeper into the atomic world, it became clear that atomic number, the number of protons in an atom's nucleus, was a more fundamental property. This realization led to a major reordering of the table in the early 20th century. This reordering was a game changer. It resolved inconsistencies and anomalies in the older versions of the table. It also predicted the existence of undiscovered elements, creating a map for future scientific exploration. The evolution didn't stop there. The mid-20th century saw the discovery of synthetic elements, elements not naturally occurring on Earth. These elements, heavier than uranium, were created in laboratories and nuclear reactors. They filled the seventh period of the table, and even extended it beyond the traditional structure. Finally, in the late 20th century, the introduction of the F block carved out a place for the lanthanides and actinides. These two series of elements, often displayed separately to keep the table compact, revealed more about the complexities of electron configuration. Each of these changes, these scientific milestones, has added new layers of understanding to the periodic table. They've helped us grasp the complex relationships between elements, uncover the mysteries of atomic structure, and predict the properties of new, yet-to-be-discovered elements. These changes have transformed the periodic table into the comprehensive tool we know today. Fast forward to the present day, the periodic table is now a vital tool in science. It's an at-a-glance guide to the elements, their atomic numbers, atomic weights, and electron configurations. It's a lot like a roadmap guiding us through the complex terrain of chemistry and physics and even biology. The periodic table's layout allows us to predict the properties of elements and their compounds. For example, elements in the same group or column have similar chemical behaviors. This is because they have the same number of electrons in their outermost shell, the layer that is involved in chemical reactions. So if you know how one element in a group behaves, you can make educated guesses about the others. In chemistry, the periodic table helps scientists understand and predict how elements will react with each other. For instance, sodium and chlorine, two elements that sit far apart on the table, combine to form common table salt. Sodium, a highly reactive metal, and chlorine, a poisonous gas, form a compound that we use every day in our kitchens. The periodic table helps us understand and predict these kinds of reactions. In physics, the periodic table aids in understanding atomic structure and quantum mechanics. Physicists use it to predict the types of quantum states that an atom can have. This knowledge is vital in fields like quantum computing and nanotechnology. But the periodic table's influence doesn't stop at chemistry and physics. In biology, it helps us understand the roles of different elements in life processes. For instance, knowing that potassium and sodium are in the same group helps us understand their similar roles in nerve impulse transmission. In medicine and pharmacology, the periodic table is used to understand the action of drugs and the metabolism of various elements in the body. It aids in the development of new drugs and therapies. In environmental science, it helps us understand the impact of different elements on our environment and health. For instance, lead's position on the table helps us understand its toxicity and its impact on human health. The periodic table is truly a treasure trove of information for scientists. So where does the periodic table go from here? We've seen it evolve from Mendeleev's basic chart to the comprehensive table we have today. But what does the future hold? The periodic table is not a static entity. It's a dynamic, ever-evolving tool that mirrors our understanding of the universe, and it has the potential to change dramatically in the coming years. The first area of potential development is the discovery of new elements. Scientists are constantly pushing the boundaries of our knowledge, and it's likely that new elements will be discovered in the future. These elements will be heavier than any we currently know, and they will reside in what we call the super-heavy region of the periodic table. The discovery of these super-heavy elements could provide invaluable insights into the nature of matter itself. Another exciting frontier is the potential for a new arrangement of elements based on quantum mechanics. This revolutionary approach could fundamentally change how we understand and categorize the elements. Instead of arranging elements by atomic number, quantum mechanics might allow us to group them by their quantum properties. This could lead to a deeper understanding of elemental relationships and the underlying principles of the universe. But as thrilling as these possibilities are, they also present challenges. For instance, how will we name these new elements? How will we incorporate them into the existing structure of the periodic table? And how will we educate future generations about these changes? These questions are not easy to answer, but they highlight the exciting uncertainty of scientific discovery. The periodic table will continue to evolve as our understanding of the universe deepens, and each new development will open up a world of possibilities for further exploration and discovery. So, as we look to the future, we should remember that the periodic table is more than just a chart on a classroom wall. It's a living, breathing entity that reflects our ever-expanding knowledge of the universe. Only time will reveal the next chapter in the story of the periodic table. The periodic table is not just a tool for scientists, it's a universal language. This profound statement encapsulates the immense importance of the periodic table in our world. It's far more than just a chart with symbols and numbers. It's a map that guides us through the complex world of atoms and elements, forming the basis of our understanding of the universe. Education is the bedrock of our society, and the periodic table serves as an essential cornerstone in this foundation. From high school chemistry classes to advanced university courses, the periodic table is a constant companion, providing a structured framework for learning about elements and their interactions. In the realm of research, the periodic table is an indispensable tool. It aids scientists in predicting the properties of elements, their compounds, and the reactions they might undergo. It's a springboard for innovation, leading to breakthroughs in fields as diverse as medicine, energy, and materials science. Beyond education and research, the periodic table is a key player in global scientific communication. It transcends language barriers and cultural differences, serving as a universally understood symbol system. It's a testament to the collaborative nature of science, fostering a global community of scholars united by a shared understanding of the natural world. In conclusion, the periodic table is not just a tool or a chart, it's a symbol of humanity's quest for knowledge. The periodic table, an indispensable tool, continues to play a pivotal role in the realm of science.